Hello, and this is the final project presentation for the Baja Strain senior design team. Um, so basically, here we go. Here's a Baja cart. And our project was to find a way that we could measure a strain on certain elements of the frame of the cart so that we could compare that to a computerized FEA analysis and the Baja team can then use that to help them gain points in their competitions. So I'll kind of take you through the final design right here. We basically took the frame and we mounted it onto a bench in the Baja shop. So down here in the second picture, this is the back of the frame. You kind of see this L-shaped. This is a very back. So we got these steel bars and we had Jeff over in the machine shop. He cut them up for us and he drilled a hole in either end so that we could get these big old 7/8 inch diameter bolts, run it through this bar into the table, out the other side, and get a nut on there and tighten it up so that we can have the frame securely mounted to the table. Because in the FEA analysis, they have um, stationary points on the frame that are held still. So wherever you apply the load, that then those points don't move, so that the rest of the frame can bend, however it would in real life. So I got these arrows marking the four bolts. There's one here, here, and then here, here at the back. Um, so this is where we secure down the frame. This is the very back. Then up here, this is kind of the midway point. Um, you see the rest of the frame is hanging off the edge up there. Um, so we got that mounted up, and then next came wiring the strain gauges together. And this proved to be one of the trickier parts of the project, just because you see these gauges here, they're so tiny. It's kind of like soldering onto a postage stamp, and the little pads are just kind of delicate, so you got to be careful with it. Basically, so this is a 90-degree biaxial T-rosette strain gauge. I'll show you a better picture of it here. These are the gauges we use. So you have these three pads, 1, 2, and 3. That's where you solder the wire onto the gauge. And then the gauge is measuring strain in this direction. And then here is where the gauge cancels out the differences from temperature. So we got our 3 wires onto the gauge. It was either 20 or 22 American wire gauge size. Solid core is preferred. Stranding works as well. And so we got those soldered, and then we had to sand down the frame. So basically this whole part here, sand it down, rough it up, starting with 200 grit sandpaper, working our way up to 400, 800 wet sandpaper. And then we would clean that off with some acetone, wipe it down. And then you would attach the wires back here, just so that when you attach it up here, you didn't have a bunch of force tugging on the wires, because this was stationary and stuck into place. So this is some hot glue. Other places we use tape, as shown back here, just to secure the wire to the frame. And then we just use super glue to attach the actual gauge to the frame right up here. So initially we started by wiring the gauge into a adapter switch that went from there into this P3500 strain indicator. And the switch was helpful because you could wire all your gauges into it, and then you just had to turn a knob to switch between the different gauges. But we ended up getting kind of some fuzzy results and some noise from the switch. So we ended up just tossing that out. and going straight from the gauge here into the strain indicator. You see the 3 wires here. I'm indicating with these arrows. Um, these are where your outside wires come in. See, this one's the red wire, or brownish here. We got the green going into the black, or the negative terminal there. And then the white is the middle terminal on your gauge in the half bridge configuration, which is here. So we got those wired up, attached to the strain indicator, and then next came applying the load. So basically we just went with a simple scenario of getting one of our team members and having them stand on the end of the frame. In this case, it's Brooks. You can see his legs here. So this is the actual FEA, and you see that the force is being applied right here, these little blue arrows. This is where it goes through on the nose of the cart. Here's your stationary points again, which is where we had the steel bars to hold down the frame. So force goes through the end. These are stationary, so we were catching the strain in these areas here, here, and then 2, 3, 4, 5, 6. I can show you a better picture of that. Yeah, here, the second picture. So we had 6 points that we wanted to measure. We were only able to get results off of 3 of those points. These 3 black circles were the ones we got results from. This one, we had a gauge on there and one of the pads ripped off, so we couldn't get readings. This point, we had a pad, or we had the gauge all wired together, and we got it on there. We felt good about it, and then we just weren't getting any numbers out of the strain indicator, which was frustrating. And then 4, we weren't able to get to because we ran out of gauges. So back to here, we get that wired up. We get our weight, force on the end of the frame here. And so then this right here is our location number 2 on the frame, and it was pretty good. We were able to get within 6% accuracy with the FEA analysis. So that was promising and encouraging. But to go along with that, location 3, we weren't able to get readings, which was frustrating. And then 5 and 6 gave us values that were well off of what SolidWorks was telling us. So we'll kind of go into the analysis here. You see here we have a J when he stood on the frame, and then we have Brooks down here. So at location 2, we're able to get pretty similar readings for calculated stress and then FEA stress. And same when Brooks was on it too. Very similar results. But then 5 and 6, not so much. You see it's about almost twice the difference here, and then more than twice here at 6. And then the same thing for down here in Brooks's situation. And I think the issue with that was we were not accounting for the elongation in this transverse direction as well. We have the axial stress, strain going along this way, but the frame is also kind of squeezing inwards at this point when you have a force going down at the end. So it's kind of bending down this way, and then this part squeezing in too, which we were not picking up readings for that with our T-rosettes. But up here at location 2, it's pretty simple. It's just going down more once you put the load on the end. This is just in one direction basically, and which was frustrating because at 3 and 4 we probably could have got pretty accurate results had this gauge been working and had we had an extra one here at 4, because I mean it's just a pretty straight shot from our load out to this point here. Um, and something else we discovered was you had to make sure you were standing still, obviously, and making sure your weight was as centered as possible along this nose of the frame, because if you were to shift your weight from one foot to the other, we could see uh, different readings in our strain. So ideally, we would have wanted to just um, gotten some hang weights just to put on the edge of this frame, just so it could pull straight down and just sit there and not move, and we could just easily load and unload it that way. Um, so here's our results from J. See, location 2 is pretty good, but 5 and 6 were off. Same with Brooks. Um, but we did get similar um, bad readings, I guess, for 0.6 and 0.5 for both cases. So at least we were consistent in our misses, but we were encouraged by the results from location 2. They seem to be pretty accurate. But overall, I think um, it was a pretty successful project. We were able to validate our results here from point 2 for sure. So hopefully they can use that and get another one up here, some more down here at the front, and get some close readings. And then I would say to um, maybe invest in some higher quality strain gauges. See here, a 3-element gauge would probably help um, in these spots here at 5 and 6, because you have more directions that the frame is actually changing. So this would be able to pick up the readings, I think, better. But in the end, it was a good project. I think I learned a lot for sure, and I think the guys did too. And we enjoyed it, and hopefully we helped out some, and still more to do, obviously, to get their full credit for their Baja events, but definitely feasible and hopefully attainable in the near future. Thank you.